Hi everyone, my name is Reggie Michelin and I work for Cybersecurity CRC in Australia, and I'm here to present my research called Leveraging Lightweight Blockchain to Establish Data Integrity for Surveillance Cameras. In this research, I will introduce a blockchain-based framework that allows to ensure the data integrity for stored video produced by surveillance cameras. Nowadays, we are facing a huge increase in the surveillance camera utilization. For example, these cameras are widely deployed in different places, such as homes, shops, malls, offices, in every kind of single building, smart city scenarios, etc. There are many purposes of using these cameras, such as inhibit trespassers, reduce theft, reduce shoplifting, and etc. Recently, the video footage produced by these widely deployed surveillance cameras started to be admitted as crime evidence and is used to support court actions. Typically, the surveillance camera are producing video streaming and storing it in private or cloud providers. And this video, once it is stored, is only made available to the authorities upon request. However, it is vital to ensure that the video used as evidence is not tampered. The video must be trusted, even when you are retrieving the video from an untrusted third-party provider. Among the possible technologies to ensure that integrity, the blockchain presents a good set of attributes that fits into the scenario and ensures the integrity, decentralization, auditability properties for proposed solution. To tackle this problem, we are proposing a blockchain-based framework. This blockchain-based framework should be lightweight because it's running in a constrained environment, as these surveillance cameras are hardware with limited resources, and the solution should also ensure a minimal latency to manage all these properties. So the proposed blockchain-based framework relies in a three-layer architecture. We have different layers. The first layer is sensing layer, where the cameras are deployed. The second layer is called transportation layer, where we have the gateways, and the third layer is called storage layer, where the video streaming is being stored. The CCTVs or smart or surveillance cameras are responsible only for producing the video streaming. Every camera has its unique pair of public and private keys. And these keys are the public key is used to identify the camera. The video is sent to the video stream is sent to the gateways, and in the gateway level, the video is handled. Every public key, every camera is addressed by its public key in the blockchain. The gateway receives the streaming and extract samples from the video stream. From each sample, it retrieves some information, such as frame rate, video position in seconds, video frame, storage address. And once this information is extracted, the framework creates a hash, computes a transaction, and this transaction is appended into the blockchain. This solution uses a blockchain called SpeedyChain, which allows to append transactions into existing block. Every block is addressed uniquely by the CCTV public key. This blockchain introduces the capability of different CCTVs appending transactions into different blocks at the same time. So once we created this solution, we execute some experiments to validate its usage. Basically, we run as CCTVs using Raspberry Pi 3s, producing some video streamings, and then we create some virtual machines that plays the role of gateways. And we are using the IPFS as a storage solution. We run the experiment considering a video stream of 30 minutes. So all this streaming, these cameras are producing 30 minutes of streaming. And at the gateway level, we are capturing this information and we are extracting the samples. For each of these CCTVs that are sending the data, we generate about 108 transactions per CCTV. At this level, on the gateway level, we measure the latency of how long it takes to manage, to extract information and introduce it and update the blockchain. On our first results, we take the time between 4 and 8 milliseconds to get this data and create this video stream, these signatures. And also on this result, we change the value of the number of connected camera per gateway from 1 camera to 32 CCTVs connected in each gateway in order to evaluate the gateway behavior with multiple simultaneous cameras. And we can see that the value starts to increase when the number of cameras reach like 16 and 32. These numbers start to grow, but still is a small growth that we measured on this scenario. So concluding our research, we use these lightweight blockchains called speed chain, and introduce a very low latency to create this transaction. So the time to manage the transaction is very small. The blockchain that we are using introduces the integrity and auditability and non-repudiation properties to the whole solution. As future work, we are planning to scale up this solution and also evaluate different blockchain implementations. Thank you, everyone.